last video, because if I again revision, it's kind of wasting the time because we spent enough time on that. However, now let me go to the cluster architecture. What is Kafka cluster? Kafka brokers are often configured to form a cluster, right? So group of Kafka brokers are nothing but the Kafka cluster. See this broker 1, broker 2, broker 3, broker 4, likewise, and see this diagram. So this diagram also showing a lot of brokers here, right? So just let me open the one PowerPoint, one moment, and keep these diagrams there to showcase you something. Give me a moment, just. Maybe let me, I think I can open the PowerPoint from here. Presentation, just a blank presentation, let me take. Fine. So go to the slide, copy, and then let me paste it here. Hope you are now able to see this, isn't it? So cluster represents the group of brokers. So group of brokers are said to be a cluster. A cluster is nothing but a group of brokers that work together to share the workload. And that's how Apache Kafka became a distributed and scalable system. Because one partition can process million records as well, but the consumer may not get those million records on fly. Maybe little latency can be occurred at the consumer side. So that's the reason we will add the more number of partitions to replicate the messages onto the partitions, isn't it? That's what we discussed. So meaning we are sharing the workload among the Kafka partitions. Each and every partition must and should have to be available on the each and every broker. So this is kind of logical class, logical session. So focus more, because we're going to discuss a lot, and then you will definitely go for a lot of confusion here as well. However, Apache Kafka becomes distributed and scalable because of this group of brokers connected together as a cluster. So we can start with a single broker in our development environment, and later on time when we go to the prod, we can increase the single broker to multiple brokers of our choice. Okay, so the latter, as the workload grows, we can increase the number of brokers in the cluster. So it can grow up to hundreds of brokers in a single cluster. So however, this clustering gives us two questions. Who is managing this cluster? Who will manage this cluster membership? And who performs the routine administrative tasks in the cluster? Right? Someone should be admin in the cluster. Right. One moment, guys. Okay, first concentrate on the session and ask your questions later. And Pavani, you said please give email ID to background team. They will share the videos. No, you have to mail to them. Okay, you have to mail to our backend team and they will share the videos. Videos are already sharing for all the folks who joined, and they already have shared, so that this video also will come. So talk to backend team if you have any issues, email to them, and then get the issues sorted it out. If not it's sorted, then let me know. I'll do something. And Amrut, could you share my email ID? To whom, Amrut? You mean to say to the backend team? No, you guys have to talk to backend team, please. Right? Okay. If you want, I will give the backend team email ID. So you guys can talk to them. If any issues you will face, then email me. I'm pinging my email ID here. If any issues you will find, still the issues were not resolved, then email me. Okay. Just by keeping me in CC, email me. I'll take it up for sure. Right. So now I believe all the non things we have done. So please keep your questions for some time, because this is the logical session. 100% you will get a lot of questions, and a lot of questions will get resolved with this one, with this session. If any question you will get in middle, try to write it somewhere and then ask me whenever I'll give the time. But don't post anything in the chat window. It will divert my concentration, because this is very, very important session. 100% you will confuse. So let me try to explain you on my level best to not to confuse and to give you the 100% clarity on the Kafka cluster setup. Okay, right, great folks. But I'll give the time for you. Please keep your questions aside. Don't ping anything in the chat. It will definitely deviate my concentration. Good. So let us start now. So what we said, a single broker we can use for the development purpose, and later in time we can as the workload grows, we can increase the number of brokers in the cluster, and maybe hundreds, thousands, or usually we don't go for the thousand, but at least hundreds, tens, the brokers we may increase. So now if the brokers are joining together, right? So who is managing these brokers? Point number one. And brokers administration, right? So who is doing that? Brokers administration. So in a typical distributed system, usual distributed system, cluster meaning there will be a master node that maintains a list of active cluster members on that master node. So the master always knows the state of the members. So in a typical scenario, if you can see anywhere, the distributed management system in the sense, let me just try to draw something. New diagram, test diagram, create. So maybe Kafka. Yes. Kafka replace, or else, yeah. Okay. In a typical environment, cluster meaning there will be a master and there will be the worker or slaves or childs. All are same. All are meant for the same. Workers or slaves or childs. Let's say workers 0 or workers 01 and workers 02 and workers 03. So we have all these workers. These workers will connect with the master. In any of the distributed system, there will be a master, and then the worker connects with this master. This is a typical distribution system. So Kafka also we are saying as the distributed. So does it contains the master? Let's see. So this is the master always knows the state of the members. This master always knows this state of these workers. Suppose a broker is active and is taking care of some responsibilities in the cluster, right? So if you can see this one. For example, let me take the new one. Paste it here. Yeah, you can see, right? So this one of the broker is active in the cluster. Okay. So if one of the broker in the cluster is active and doing some work in the cluster, suddenly that broker leaves the cluster or dies for some reason. Now at this stage, who will perform those responsibilities? So we need someone to reassign that work to an active broker. 1 minute. Sorry, guys. So suppose a broker is active. So this is the active broker. Suppose a broker is active. And if this active broker dies or suddenly crashed due to some reason, right? Now at this stage, who will perform these responsibilities, this broker responsibilities, who will perform, right? Or who will assign someone to perform the responsibilities of this broker, right? So who will do that? So zookeeper, zookeeper. See here. So this broker is down or maybe died some reason, and this may be doing something, this may be doing something, this may be doing something, right? Who will takes care of shifting its responsibilities to some other active broker or some other broker by making it as active? Who is doing that? Zookeeper. So Kafka broker is a masterless cluster. So here, not Kafka broker, Kafka architecture is a masterless cluster architecture. So there is no master. There is no master among these brokers. No master. It's a masterless. So it does not follow a master-slave architecture like as I have shown here. Our Kubernetes following the master-slave architecture. Jenkins supports the master-slave architecture, right? Ansible supports the master-slave architecture. But our Kafka architecture is not the master-slave architecture because all the brokers in the Kafka architecture are participating doing the responsibilities. There is no manager, all are workers. So that is the reason it is said to be a masterless architecture. Okay, and it doesn't follow the master-slave architecture. Then who will orchestrate or who will control these brokers? So zookeeper. So Kafka architecture uses the zookeeper to maintain the list of active brokers. So here, if you can see in the above diagram, so we have these are all the active brokers, right? So this list of active brokers will be managed by the zookeeper. So here is the zookeeper. So every Kafka broker has a unique ID. So if you can go and then see our Kafka multi-node cluster. 1 moment, Kafka multi-node cluster, if we can open, not this one. another folder where we have the Kafka stuff. Just let me scroll down. See. Okay, otherwise, let us add that folder here. What I mean to say is, go to the C, Kafka, and till here, let us add that folder. Add folder to the current workspace. Trust it. Now you can see this workspace contains two folders. One is our multi-node cluster architecture, and second one is the Kafka where we installed it. So if you can see this Kafka config, broker 0.properties, if you can see, each and every broker have a broker ID, correct? So broker 1, so in the broker 1, we gave broker ID as 1. That means each and every broker have a unique ID that we define in the broker configuration file. We also specify the zookeeper connection details in the broker configuration file. So for example, this is the broker 1. Somewhere we can see the zookeeper connectivity details. So scroll down to somewhere, we can see the zookeeper details, right? So zookeeper connectivity details. So every broker will have a unique broker ID, and every broker will connect to the zookeeper. To connect to that, every broker have the zookeeper details with it. Only one zookeeper or many zookeepers also we can maintain, but ideal case one zookeeper is good enough. If it will go down, then another zookeeper should have to become. So zookeeper also should be in the replication. That is different story. But right now, only one zookeeper, whereas all the brokers are being controlled by this zookeeper. Okay, when the broker starts, it connects to the zookeeper and creates an ephemeral node. Ephemeral node using the broker ID to represent an active broker session. What it means is, when the broker will start, it is creating a ephemeral node, right? This ephemeral node using broker ID. So broker 0 or usually partitions topics are creating, and here broker, whatever the broker file it is created, and inside the zookeeper also it will create what the ephemeral node in the zookeeper database. Zookeeper in memory database, it will have the ephemeral node. So go to this Kafka. I think we can't see that now, but go to Kafka, Windows. I can showcase it by connecting to the Kafka server using by connecting to the zookeeper server using the zookeeper shell. But right now, what I mean to say is this ephemeral node is nothing but a temporary node. If the zookeeper will down or die, this node will go. If the zookeeper is there, until that time, this node will be there. So that is the meaning of the ephemeral. That means it is temporary. Every broker who is connected with the zookeeper, in the zookeeper with the broker ID, an ephemeral node is created to represent the broker session. The ephemeral node remains intact as long as the broker session with the zookeeper is active. When a broker loses the connectivity to the zookeeper for some reason, then the zookeeper automatically removes that ephemeral node. So the list of active brokers in the cluster is maintained as the list of ephemeral nodes under the broker/IDs. So this broker slash IDs is what the path where we can see all the list of brokers. So I can showcase you that now. To showcase that, first let me start the Kafka cluster, meaning first let me start the don't save. So first let me start the zookeeper. So I'm at here, cd space commands, and let us start the zookeeper setup.bat. Perfect. Now the zookeeper is started. Go to broker one and set up broker 0 setup. Okay. Now broker 0 is what? Connected to the zookeeper. So how we can see that? So go to here, open command window, zookeeper-shell, zookeeper-shell space. We have to connect to, meaning in order to see, we have to connect to that. So zookeeper-shell and give the zookeeper host name, localhost, and then zookeeper port number 2181. Now we connected. Welcome to zookeeper. Now if we can see list, we can see one command, that is ls. So let us type just /ls, meaning list ls space slash. If we type, so these are all the ephemeral nodes on the zookeeper. So controller is one ephemeral node, cluster is one ephemeral node, brokers is one ephemeral node. Now, if you want to see the brokers ephemeral node created, so brokers slash IDs. Now see, 0th broker is there in the zookeeper's database, in-memory database, under the path broker slash IDs. So what, again, let us go back to here and then rephrase the sentence. When the broker starts, meaning I just have started the broker 0, and that broker 0 connects to the zookeeper. As soon as it connects to the zookeeper, under the zookeeper, a ephemeral node is created with the broker ID. With the broker ID. And this ephemeral node is there inside the zookeeper as long as the broker is active. If I stop the broker, so for example, let me go here, and then if I stop the broker, so Control C, I'm just stopping the broker, trying to stopping the broker. I pressed Control C. Yes, now broker stopped. So when broker stopped, I have given the wrong command. So just give ls space slash and ls space slash brokers slash IDs. Now no broker, because broker registered in the zookeeper and created an ephemeral node for that broker with the number broker ID. And that broker ID, meaning the ephemeral directory inside this broker slash IDs, will be there till the broker connected to the zookeeper. Once the broker is disconnected from the zookeeper, zookeeper deleted that ephemeral node from this zookeeper's in-memory database, or in-memory we can say simply. So that is what the meaning of this one, right? The ephemeral node remains intact as long as the broker session with the zookeeper is active. When the broker loses the connectivity to the zookeeper for some reason, then the zookeeper automatically removes that ephemeral node. So just now we have seen that. So the list of active brokers in the cluster is maintaining as a list of ephemeral nodes under the /broker IDs. So let's go here and then again start the broker 0 and go to this broker 1. Again start the broker 1 and go to this broker 2. Again start the broker 2. That's it. Now one zookeeper with the 3 brokers connected. Then if we go to again the and then enter this one, now we can see 0, 1, 2. So 3 brokers were now registered with the zookeeper, and zookeeper created an ephemeral node under the /brokers/IDs with the broker ID numbers. These broker ID numbers we were configured in our broker properties file or server.property file. Make sense? Right. I think you now understood how a broker is connecting to the zookeeper. So this is what all the brokers are connecting to the zookeeper. Each and every broker will be identified with a unique integer number. And all these unique integer numbers, with all these unique integer numbers, zookeeper will create an ephemeral node inside this /broker/IDs. Excellent. Now we understood, right? So now we understood. So if you want to see brokers, this one. Now if we let us stop the broker ID 1, then broker ID 1 gone, we have the 0, 2. And now the broker ID 1 gone from the zookeeper. If we again start the broker ID 1, then we can see the broker ID 1, right? So this is how the Kafka will maintain the list of brokers in the cluster. So list of active brokers in the cluster is maintained as the list of ephemeral nodes. Very, very important, because this topic will be input for other topic to understand. So the list of active brokers in the cluster is maintained as the list of ephemeral nodes under the broker/IDs path in the zookeeper. Perfect. Now let us understand what is controller. So before understanding what is controller, do you have any questions in the section how a broker connects to the zookeeper? Any questions? Any questions? Or are we clear?
So just
Sir,
one doubt. Yeah, go ahead.
yeah, go ahead. Right, sorry.
Yeah.
Okay,
Great.
sir. So I have one doubt, sir.
Yeah.
So in the previous class, like we saw, like once we are producing or consuming, it was only from the master node, right? So, but here we are saying like it is a masterless cluster.
Correct.
So it's just confusing.
Okay. So here in the, okay. I think that question will be answered once we discuss about this controller. Okay, because that is however I have to explain. Let us see this. This concept completed, then you will get the clarity. Okay. So
So,
Kafka.
oh, sorry. In the previous one, where you showed the IDs where it's 0, 1, 2, basically, if 0 goes down, then 1 becomes the master, or is it in the same order? Does it go, or it changes in
That
the
is
above
what.
one?
Okay. Okay. Here we should not call it as master. First of all, brokers are masterless. Point number 1. Point
Okay.
number 2. These brokers are registering with the zookeeper with the broker IDs. That is only we discussed. We have not discussed about one will down, who is the master, who is the, no, we have not discussed. We will discuss. That is the concept of the controller. Let us now
Okay, sorry.
discuss. Yeah, yeah.
Thank you.
Sir, I
Yeah.
have a question like master node you mentioned, right, sir, in the slide.
Sorry, what is that?
Master node.
Correct. Huh.
So means like master node is nothing but zookeeper, or what can I just
No, here, okay. What I have given here is generally If
Okay.
it is a Kubernetes, or if it is a Jenkins, or if it is an Ansible, we will have one master where all these workers will join to that master.
Yes,
So
sir. Means in
this
the previous slide you have shown master node, na? That's
that is not master node actually. I have not used the word called node. I just mentioned master. So here coming to the Kafka, in these brokers, no one is the master. No one is the master. So these brokers all connected to this zookeeper. Am I audible? Can anyone please confirm? Am I still audible? Am I
now
with you
audible,
guys?
sir.
Yeah,
Previously we lost.
yes, yeah. Sorry, power gone for me. Yes, I connected from the mobile. So what I'm saying is here, zookeeper is not the master. There is no master node. Node meaning one machine, isn't it? Here we are discussing about the single cluster, single node. Single node meaning my laptop. My laptop is one node. On my laptop, we were ran the zookeeper, we were ran the broker 0, broker 1, broker 2. So there is no multiple nodes here or multiple machines here. Point number 1. Okay. Though we have the multiple machines, zookeeper we will install on machine 1, broker 0 will goes to machine 2, broker 1 goes to machine 3, broker 2 will goes to machine 4. So even though these were distributed, those machines are not said to be a master machine and then slaver machine. No, it is not master slave. So if it is master slave, the slaves will connect with the master with one token, with one token. But here the workers are connecting to the zookeeper, not to the another node. No, or not to the another node, or not to the another orchestrator who will do all the orchestration activities. No. So zookeeper is the person who is managing these brokers, who is monitoring these brokers, and the brokers are connecting with the zookeeper with the broker IDs, right? So here, zookeeper will know about the brokers because the brokers are creating under the zookeeper. But in the master slave architecture, these slaves will be created somewhere. Master will be created somewhere. Both will be connected together, either using the TCP/IP communication or SSH communication, or maybe the token communication. So master don't have the worker node information or worker node here, not information. Master don't have the worker node. Master don't have the worker 2. Master don't have the worker 3 here. In general, master slave architecture. So slaves are somewhere, master is somewhere, both are connected. But in the case of zookeeper, what is happening? In the case of zookeeper, the zookeeper is maintaining or creating the ephemeral nodes for all the brokers. So that means if this is the broker 1, just in case this is the broker 1, so it is creating the broker, sorry, control J. It is creating the this broker 1 ephemeral node here, and broker 2 ephemeral node, broker 3, broker 4. Likewise, it is creating the ephemeral nodes of the brokers. And does zookeeper know about these active brokers here? But here the architecture is different. Workers are independent nodes, master is independent node, both are connected together via an TCP/IP communication or SSH communication or token communication. But here not like that. So the brokers, whatever or we are creating or we are starting, those brokers, for those brokers, an ephemeral node will be created on the zookeeper. That's how the zookeeper knows about these active brokers. Hope you all got the difference, right? Probably got the difference. Clear? Questions are clear? Done right? Guys, am I audible?
Yes, sir, you are audible.
Yes, yes. So I believe questions are clear, right? Probably. Right. Now let's move on to the topic called controller. So Kafka is a masterless cluster. Now you understood the meaning of this masterless, I believe. Kafka is a masterless cluster and the list of active brokers is maintained in the zookeeper. This is the location. However, we still need someone to perform the routine administrative activities such as monitoring the list of active brokers and reassigning the work when an active broker will goes die or leaves the cluster, right? So all those activities are performed by a controller in the Kafka cluster. Carefully observe, please. Carefully observe. Please carefully observe. You will confuse here. You will confuse here. 100% you will confuse. What we are saying, all the brokers are connected to a zookeeper, point number one. So zookeeper know about these active brokers because because the brokers will create under the zookeeper/broker/IDs, right? There the brokers will be created so that the zookeeper will know about the active brokers. But when some of the broker will die or leave the cluster, the responsibility or the task which is performing by this broker should have to be distributed to any of the available other brokers. So we will do that task management. The task management is doing by whom? The leader or the controller. Like in your team, your manager will take care about the resources, whereas your lead take care about your tasks. Similar case here. Zookeeper is taking care of the brokers, and then inside the brokers, the task execution, task monitoring is taken care by one of the broker called controller in the cluster. So the controller is not the master. Control is not the master. It is simply another broker that is elected as a controller or leader to take up some extra responsibilities. Hope it is clear. So now, who is the leader or who is the controller? How we came to know? So that means the controller also act as a regular broker, who is also a regular broker. So if we have a single node cluster, it serves as a controller as well as a broker, both. In single node cluster, if we take the 3 brokers, 5 brokers, among those 3 brokers, 5 brokers, one broker will be act as a leader or controller and also act as a broker. So there is only, however, there is only one controller in Kafka cluster at any point in time. This is very, very important. So there will be at any point of time, only one controller in the entire Kafka cluster. No matter how many brokers we have. Right now we have 3 brokers. Maybe tomorrow we may have 100 brokers. No matter how many brokers we have, but out of all those brokers, one will be only the master. Sorry, not master, leader or controller, not master. We should not use the word called master here. We have to use the word called controller here. Okay. So the controller is responsible for monitoring the list of active brokers in the zookeeper. When the controller notices that a broker left the cluster, it knows that it is time to reassign some work to the other broker. It is time to reassign the work of that leaving broker to other. For example, you resigned. You resigned. Then your lead will do what? Whatever the tasks that were in your bucket, those tasks will be distributed among the team. That is the job of your lead, not your manager. Your manager is taking care about your exit formalities, or how the broker will go out. So those are all the things will be taken care by the manager. But if the broker will go out, who will do the work of that broker? So that's what the controller will decides to have, who the controller is responsible for distributing or reassigning the work of the other broker, or leaving broker, to the other brokers. The controller election is simple because the first broker that starts in the cluster becomes the controller. Here, if you can see, for example, let me stop all these brokers. Okay, let me stop this broker 2. Let me stop this broker 1. And let me stop this broker 0. Perfect. So I'm stopping all these brokers now. Maybe they went to kind of sleep mode, but okay. Yes, slowly they are responding back. I'm just stopping the brokers. Broker 2, I'm stopping. Broker 1, broker 0. Seems to be zookeeper is the one who is not responding. I'm again starting the zookeeper. Perfect. Now broker 2, I'm stopping. Broker 1, I'm stopping. Carefully observe this step, please. Broker 0, I'm stopping. Now zookeeper is, however, running. So see, first let me start the broker 2. Okay, first I am starting broker 2. Let the broker 2 start. Then I am starting broker 0. Then I am starting the broker 1. Perfect. Now out of these 3, who is the controller? Broker 2 will be the controller because broker 2 will start it first and then connect it to the zookeeper. So let's go and then see that. Let me just take one command prompt here. Start local terminal. Zookeeper -shell. Let us connect to the zookeeper localhost 2181. Oh, zookeeper shell is not identifying as the command. Let me just okay. So zookeeper -shell is the command. So let me go to C drive, CT. Yeah, I'm in now C. Let me go to Kafka and let me go to bin Windows. Right. So here let me type zookeeper -shell. I just chosen this to have some colors and all. Right. This is little colorful compared to the black window. So zookeeper shell localhost :2181 is the zookeeper port. Zookeeper shell is not identified. Okay, no problem. Zookeeper -shell dot bat. One moment. Let me go to here, Windows. Yes, I'm in Windows. Now here we can see the zookeeper shell, zookeeper-shell. -back. Now let's connect localhost :2181. This is not detecting. That's okay. This terminal is not detecting. So let us go back to again our command prompt. And from here only let us connect. Perfect. Now we connected. So let us see ls/l, which are there under the zookeeper. Now we want to see, so far we have seen the brokers. Now we want to see the controllers. So ls/controller. Sorry, we should not use ls. We have to use get/controller. Now what is the controller? Broker ID 2 is the controller. Why? Because we started that broker ID 2 first. So it connected to the zookeeper first. So it is taken as a controller. Now assume, let us stop this broker ID 2. Yes, I'm stopping. Now who is the controller? Right? Because controller is stopped or left the zookeeper or left the cluster. So now broker ID 1 elected as a controller. So now let us start the broker ID 2 again. Broker ID 2 again. Yes, it connected. Now see, still broker ID 1 is the controller. Now what happened? Broker ID 2, which is the controller at the beginning, has lost its ownership or controllership when it leaves the cluster. So when the broker ID 2 left the cluster, immediately zookeeper elected one of the available broker as a controller and start serving the one of the broker, that is broker ID 1, as a controller, meaning extra task monitoring activities it is doing. Again, when the broker ID 2 back, still the ownership is with the controllership is with the broker ID 1 only. So broker ID 2 lost its ownership. Got it? So this is how we called as controller, not the master. Okay. So when other brokers start, they also, here how this controller will be elected. First of all, are you clear with this controller broker? What is controller broker? Just what is controller broker and how the controller broker will be, I mean, who will elect the controller broker among all the available broker. Now, how the controller broker will be elected? See this is very important point. So when the first broker starts in the cluster, becomes the controller by creating an ephemeral node in the zookeeper. When other brokers start, they also try to create this node, but they receive an exception as node already exists, which means that the controller is already elected. So in that case, they start watching the /controller node in the zookeeper to disappear. To disappear in the sense, when the /controller node becomes empty, like this empty, then the available other brokers will start to promote themselves as the controllers. So when the current controller dies, the ephemeral node disappears, then every broker, every other broker again tries to create the slash controller node in the zookeeper, but only one succeeds among them, and that other gets the exception. So basically, what did you understand now? What is the broker that is initially starting in the cluster, connecting to the zookeeper? That broker will create the slash controller ephemeral node. That is the reason when we query it, we are getting the broker ID as 2. So once this, when let's say I have started the broker ID 2, very beginning time. Next broker ID 1 I started. So broker ID 1 also trying to create this slash controller directory under this zookeeper, but it failed because already the slash controller ephemeral directory was already there. So the broker ID 1 will get an exception saying that the controller already existed. Again, when we started the broker ID 0, broker ID 0 also tried to create this controller. So every broker, when it started trying to create this slash controller directory under the zookeeper. But if one will be succeeded, then that one who succeeded is called as a master. Sorry, controller, not master, controller. Is this point clear? About the controller is clear? 3 points.
Yes.
Yes, so how the controller will be elected? Who will elect the controller? And what in case the current controller dies or leaves the cluster? So these 3 points should have to be understood to you by this discussion.
Sir,
Excellent.
one point, sir. When
Yes.
the current controller goes down, so
Yes.
suppose there are multiple broker available in the cluster right now. So
Hmm.
zookeeper will collect any one of the broker as the leader now, right? So it will be based on the time system when like second broker connected to the cluster, it will be elected as a leader, or it will be round robin.
It is round robin basically.
What is round robin? Okay.
Round robin. So we'll discuss about them. There is two
Because
algorithms, hash key algorithm and round robin. Going forward, we'll discuss them.
okay, because we are seeing here like once the controller 2 goes down, so
Hmm.
uh, like after the broker 2, we cluster got connected with the broker 1 and it has elected as a controller. So that
Correct.
was that's
Correct.
why
Correct.
my doubt
Correct.
came.
Correct. Correct. But in the order we have started, broker 2 first, broker 0 next, and then broker 1 next. Correct? That order we started. But it elected broker 1 as the next one. So it is obviously the round robin based on the available
Okay, sir.
time available
Thanks, sir.
of the brokers. It is. Yes. Okay. Great, folks. So I think you are now clear with this controller concept. Okay. So this is what now explained in this document so far here. Done. Now, the next concept is partition allocation and fault tolerance. Very important. Last week, so many members were asked, sir, we are creating a topic, and that topic, when we are creating, we given the partitions, number of partitions, isn't it? So for example, create topic commands. Go and then see this create topic. Yes, so here we have given the number of partitions and replication factor also to duplicate this, to have a copy of each and every partition and each and every node. We have given replication factor as well. So many of the members were asked, so how these partitions got allocated? So very important topic, 100% you will confuse. So let us try to understand more. So far we discussed in the last weekend, we discussed about the partitions and log files, like creating the topic and creating the partitions and understanding the replication factor, understanding the log file, index file, right? Segment, and how the segment is maintaining the indexes, All those things we understood in the last weekend. And today we understood the cluster formation, how the cluster is forming. There is no master. All brokers are connected to the zookeeper with their broker ID. Among all those brokers, the broker who is connecting to the zookeeper first will be elected as a master, sorry, controller. Pardon, I'm using keep on this master word. No, not master, controller. And controller will do the extra activities like monitoring the tasks of the other brokers. And when any active broker will leaves the cluster, then that task of the leaving broker will be allocated to or distributed to other brokers by this controller. That is the job of the controller. So these two informations we learned so far.
Sir, one
Now,
doubt, sir. Sir, one doubt. Can I ask, sir?
yeah,
Sir,
please go ahead.
sir, like one broker is taking additional responsibilities of distributing the tasks, right?
Mm,
So, will
mm.
there be any performance impact considering two of the broker? One is one who is leader and one who is not a leader. Is there any impact in the performance once
No,
we
no, no.
produce and consume the data from the partitions of
Understood. Understood. So the producing and then consuming data is based on the few of the factors, meaning there is a committed message, uncommitted message. The other factors are there. The performance will be affected due to the other factors actually, but not exactly this one. Elected as a controller, maybe doing the extra responsibility, it is spending time there, so its productivity or maybe its performance will get down. So that is not the matter for the performance. The performance will be depends on the committed and uncommitted logs. So we'll gonna discuss them the going forward. Fine. So if we look at the Kafka topic organization, in the last week, we created one topic. Assume here invoice is the topic, and the topic is just a logical entity. Topic is just a name. And for that topic, 100%, at least one partition will be created. If you don't give any hyphen partitions while creating the topic, if we don't give any partitions, at least one partition will be created with the number 0, right? Right? So for every topic is a logical name, but the physical directory for that topic is called as what? The partition. So here assume invoice is a topic and we have the 5 partitions, P0, P1, P2, P3, P4. Assume each partition is self-contained. That means what? Each partition having its own set of segment files, index files, log files inside the each partition. You can see here, StockTix2 is one partition which contains its own log files. Similarly, StackTix1 is one, let's say broker 2. StackTix2 is having its own log files, index files, snapshot files, right? And then StackTix1 is also having its own log files, index files, and all. So that means each and every partition having its own segment files, index files, log files within that partition only. And hence that partition is said to be self-contained. So each and every partition is now said to be self-contained. Okay, great. So this is the invoice topic, and this is the partition created. Each and every partition have the files inside in it, so that it is said to be self-contained. Perfect. Now, so this structure is allowed. Now we can see broker 0, broker 1, broker 2, broker 3, broker 4. Like we have the 5 brokers. 5 brokers having the 5 partitions. Each partition is having their own segment files, index files, and all. Assume. So this is allowed to distribute the work among the Kafka brokers in the cluster efficiently. So because Here the invoice P2 is here in the broker. Let's say 0, 1, 2, broker 2, we have the invoice P2. The same invoice P2 definitely be on the other brokers as well. So that's how it will be distributed. Because if you mention the replication factor, then what will happen? This topic will be there. This partition will be there on the other brokers as well. So Kafka brokers will be meant for distribution in the cluster. So just we need to do what? We need to spread the responsibilities of the partition in the cluster. That means here invoice P0 is there. We just need to spread this invoice P0 partition to other partitions as other brokers as well, just by keeping a replication factor, something like that. Correct? So when we create a topic, the responsibility to create, store, and manage partitions is distributed among the available brokers in the cluster, because we will create the topic with the hyphen partitions and hyphen replication factor as well. So that means every Kafka broker in the cluster is responsible for managing one or more partitions that are assigned to that broker. Now, let us see these partitions, how the partitions will be allocated. Very, very important. Very, very important. Hope you are understanding the concept. So partition allocation. Carefully observe. This is the core of the concept that we are discussing. So Kafka cluster is a group of brokers. We know that. And these brokers may be running on individual machines. As I told, that will be our next exercise. On AWS machines, we will set up these brokers on individual machines. That is our next exercise. So these brokers may be running on the individual machines. Maybe broker 0 on one EC2 machine. Broker 1 is on one EC2 machine. Broker 2 is on one EC2 machine. Zookeeper is on one EC2 machine. So like this, we will distribute them. So we'll see that architecture. That is our next exercise. So these brokers may be running on the individual machines or maybe on the same machine. So in a large production cluster, we might have organized those machines in the multiple racks. Correct? So the below configure shows a 6-node cluster. 6-node cluster that is designed using 2 racks. So here you can see this is one EC2 machine, assume. This is one EC2 machine. This is one EC2 machine where broker 0 is an EC2 machine. Broker 1 is another EC2 machine. Broker 2 is another EC2 machine. And these EC2 machines we were taken from the AP South 1A region. Understood? Mumbai. So I'm talking about this one. Probably, yeah, we already started drawing something, right? So this is the one I'm talking about. This is the one. So we have the, usually we have the VPC. Correct? So let's say this is the VPC. In this VPC, we have the subnets. Let me check available zone. So this might be AP South 1A availability zone. If it is Mumbai region, so this is AP South 1A availability zone, and this is assume AP South 1B. Exactly the same architecture we will create. Okay. Now in this AP South 1A, we have the 3 machines. So these are all the 3 machines we have on the AP South 1A. Assume. Perfect, right? Hope you are getting me. In AP South 1A region, we have taken 3 machines. So just for naming sake, every time we can't say AP South 1A, AP South 1A, right? So let us term it as a rack, simple rack. And similarly, in AP South 1B region also, let us take these EC2 machines and let us install the or set up the brokers, that is broker 3, broker 4, broker 5. Perfect. So this is what the meaning of the rack. Here rack meaning availability zone in the AWS. Okay, if we set it up on the AWS or any cluster, it is kind of an availability zone here, rack meaning. But every time we can't say rack, availability zone, right? So that's the reason we termed something like rack 1, rack 2. This is clear, I believe, correct? Perfect. So now let us understand the partition assignment with an example. So let us say we decided to create a topic with 10 partitions and 3 replication factors. Now, can anyone tell me if the 10 partitions and 3 replication factor, then what is the total count of partitions? Anyone can guess?
30, sir.
30.
Exactly. 30.
32.
30. And we have the 6 brokers. That means each and every broker have the minimum five partitions. Exactly. Perfect. Now let us see that use case. So partitions 10, replication factor 3, total replicas are 30. So these are the brokers. This is broker 0, broker 1, broker 2. Remember guys, here B0 box is there now. This is one EC2 machine. Rack 1 meaning AP South 1A region assume. Rack 2 meaning AP South 1B region assume. And we have done this cluster setup in the Mumbai region. So if it is Mumbai region, then that is called as AP South 1. That's it. Understood like that. Okay, perfect. Now, so when these partitions are distributing onto these 6 brokers, Kafka tries to achieve 2 goals for this partition allocation. One is partitions are distributed evenly, like that, meaning just now we said, 6 brokers we have, 30 partitions we have, minimum each and every broker will get 5 partitions. That is even distribution. Correct. Second one is followers, duplicate copies. So duplicate copies are placed on different machines to achieve the fault tolerance. That is the meaning of, right? So why we are going for the replication factor? To have a duplicate copy of the partition. Partition 0 may be like this one. We already have done this. See this one? Partition 0, partition 2, partition 1 on broker 2. Same on broker 1. Same on broker 0. This is to what? This is to achieve the fault tolerance. If the broker 0 dies, no problem. The broker 0 messages were already copied onto the broker 1 and then broker 2. Then the broker 1, broker 2 will start giving the response in the absence of this broker 0. That is the fault tolerance, isn't it? Similarly, here, each and every message, each and every partition should have to be duplicated on each and every broker to achieve the fault tolerance. So to distribute these 30 partitions, Kafka applies the following steps. So make an ordered list of available brokers. That is the first one. Then assign leaders and followers to that list. Okay. And carefully observe, this is very, very important, guys. So Kafka starts by making a list of available brokers. So here we have the list of available brokers. In this one, it begins with a randomly chosen broker in a rack and alternates with another broker in different rack. For example, see here, it is trying to creating the list of available brokers. So from the AP South 1A region, it chosen one machine where we set up the broker 0. Right? This is from the AP South 1A. Then the next time, when the next broker in the list must be from a different rank. So it will be like B3. B3. Now these two are done. Then it will go to once this, then this, then it will go to this one, rack 1. So now it will be B1. Then once this is done, then next B4. So it will be B4. So like that, what it will do is all these 6 brokers will be put into one list of active brokers. Now list of active brokers list is what? This one, B0, B3, meaning how this got? B0, B3, B1, B4, B2, B5. So this is what the list of active brokers list. So we can see B0, B1, B2 are one rack, B3, B4, B5 are from another rack. And we have these partitions, P0, because number of partitions we have given as what? 10. And replication factor is 3. So 10 number of partitions are first leader partitions. Then next replication factor is 3. So 1 is already here. The remaining 2. So these 2 partitions are said to be the follower partitions. I believe till here it is clear. So now what is fault tolerance? So it is as simple as make sure that if one broker fails for some reason, we still have the copy of the other broker on the other machine. So if the entire rack fails, for example, AP South 1 year region entire is not working, no problem. AP South 1B is there to serve the messages, right? Because the backup of all these brokers is also there on AP South 1B. Perfect. Now let us assign the leaders to the followers. Let us assign the leaders and followers to the list. List meaning list of active brokers. So we have here from this list, you can see these many are what partitions we have. So let me paste it something here. Actual size. Okay. Now, how these partitions will be allocated to the brokers? So broker 0 will get leader 0. Broker 0 will got the leader 0. Then broker 3 got the P1 partition. And broker B1 got the P2 partition. So like that, we'll get all the brokers with the leader partitions. So B0 got the P0, B3 got the P1, B1 got the P2. So like that, all the leader partitions were mapped to the available active brokers. Then the assignment of the followers will be start by leaving one broker. So once the leader partitions are created, it start creating the first follower. The first follower allocation simply happens from the second broker in the list and follows the round robin approach. So from here, the next follower will be created. So follower in the follower, P0 is the partition 0. So that will become to P1. Then again, P2 come to here, P3 come here. Likewise, all the followers were also filled. Similarly, next followers. When it go to the next followers, it will use these 2 brokers and it starts from the 3rd broker and it will fill all the other followers. So this is what happens when we create a topic. And leaders and followers are the topic created across the cluster. So if we look at the outcome of the above allocation, we couldn't achieve a perfectly even distribution because the broker 4 got 4 partitions. The broker 0 has got the 4 partitions. Broker 0 has got 4 partitions, P0, P6, P5, P4. Whereas the broker 4 got 6 partitions. Broker 4 got 6 partitions. So we are not evenly distributing, right? So however, we made an ideal fault tolerance with a little disparity. We are not ideally maintaining the perfect even distribution. So the even distribution is maintaining maybe by having the more copies on one broker, maybe less copies on another broker, but each and every node, meaning each and every broker, that means each and every partition is now definitely on the other partitions. You can see P0 is on the B3 and P0 is also on the B1. So this B3 is from different rack, B1 is from different rack. Okay. So let us take a small break, guys. I believe this is confused you. Let me re-explain one more time, but I need just 5 minutes break. Okay. So let us take a 5 minutes break. Not 5 minutes. Let us take 10 minutes break because this concept is important. Come with some fresh mind. So 10 minutes break. Let us again start by 10:45 a.m. IST. 10 minutes
Sir,
break.
sir, we'll experiment this one, right? The failure case.
Yes, we'll experiment that one.
Okay. And one more thing, just related to that one only. Suppose one consumer misses any of the right topic. It may chance, right, that something happened in the network and some topic not consumed properly. That may happen, right? So in that case, how to handle?
That is our next concept. There is a concept called ISR, in-sync repeaters.
Okay, got it. Every time I am thought to one step ahead.
Yeah. Obviously, topics are like that in Kafka. Yeah, go ahead.
Sir, one question, sir. I think, sir, it brings the most important thing, like being a developer, when there is need to create any topic, so we have to take a call, how many partitions should be there, and what should be the replication for this. Then what are the deciding factors, I think?
Load, nothing but load. How much load we are getting? Meaning producer can produce how much events at a time, or they are continuous, or maybe event based, or maybe trigger based. So there are 3 options that we have to
Sir,
consider the.
Can you explain?
Okay. Otherwise, let us come back from a small break and then with a fresh mind, let us discuss that.
Okay.
Yeah,
Sir.
sure.
Thanks a lot.
I'll be in mute. I'll be back by this 10:46 exactly. Hello all, I'm back. Hope you're also there. Sorry, I was taking 4 minutes extra. 5 minutes extra I was taken. However, yeah. So let me answer the first question. So what is that first question? How we can decide? So what are the best practices to decide the number of partitions and then the replication factor? So the best practice is always the throughput, how much throughput that we wanted to send and then consume. So based on the volume of the data, and then second is frequency of the data, and third is consistency of the data. So these three are the major factors. How much data we are sending and how frequently we are sending, whether it is continuous per second, per millisecond, and consistency of the data. So meaning we want to have the same data, any number of consumers will consume it, or any number of producers will produce it. So these are all the three factors major. We'll go for the replication factor and then the partitions. So for example, we are getting the data through the reconciliation system. That means the reconciliation system in the sense, probably I have the, let's say there were three banks, HDFC Bank and ICICI Bank or SBI Bank. So from these three banks, let's say we want to get the data, right? So we have the three banks. This is one bank and this is another bank, and then this is another bank. So here is my reconciliation system. So this reconciliation system, how frequently it is getting the data from the source systems or source of systems. So this is one, and then this is one. So what is the frequency? It is continuous stream, or it is event based, or event trigger. If it is continuous stream, obviously we have to go for high available cluster with the more number of partitions and then more number of replication factors. If it is not a stream, maybe an event, then we may not require those many partitions or those many replications. It depends on either it is stream or whether it is event and how frequent it is coming to our producer. So this guy is the producer. Then this producer will produces those messages to the topic, meaning number of partitions, right? On the other end, many consumers will get those data. So this is clear, right? The first, meaning the question for the answer for the first question. Got it? Probably you got it. Okay. Now, let us understand these assign leaders and followers to the available list one more time. Let me explain this one more time, because I don't know whether you understood it properly or not, but let me try to explain it in a different way. This is very important to understand. So that's how. So let me take one slide, and in this slide, let me take this partitions. So in that slide, let me take these partitions. So we have the partitions and we have the brokers. Fine. Partitions and then the brokers, or else let us take this complete figure. Partitions, brokers. Let's put them here. Don't think I'm wasting time. I'm trying to explaining in a more efficient way because this is important concept. So go here. So let me delete this. Okay, let me copy and then paste. Here, let me take this one. Control C, Control V, escape. Perfect. I could have prepared the slides and then come back. Sorry for that. Those may give you the good picture on it, but let me try to do that even right now. Yes. So this is what the partitions and then allocations, partitions, brokers, and then the leaders. What will happen next is, carefully observe, please. The first partition in the list will be allocated to the broker 0. So here we have the P0. Na? This P0 will be allocated to broker B0. Then next, again in the list P2, P1 is there. So P1 will go to B3. So how this B1, B2, B3 were identified? This B0, B3, B1, B4, B2, B5, how they were identified? Identified from the rack one broker elected as an active broker and then added to the list. Then rack 2, another broker. Rack 1, again another broker. Rack 2, another. So alternative way, in round robin fashion, alternative way, the brokers will be collected into an active list, active brokers list. Now we need to assign the partitions, 30 partitions onto these active brokers. So P0 will come to B0. P1 will come to B3. P2 will come to B1. P4 will come to B4. P5 will come to B2. P6 will come to B5. And then P7 will come to again B0. And like this, all the leader partitions will get filled. So this is how all the leader partitions will get filled. Once the leader partitions are done, see this? We don't have the leader partitions. So you can see these leader partitions are done, filled here. Next, follower partitions. Follower 1 partitions. So follower 1 partitions, like follower 1 partition P10. So P0 will come to this place, broker 3, because the P0, follower P0, here the follower 1 partition P0 will come here by switching or by escaping the broker 0 here. By escaping one broker, the P0 will come here. Again, P1 will come to here. P2 will come to here. Like that, it will be filled. Follower 1 partitions got filled like this. Then once these got fixed, then these are all the remaining. So those remaining now go to the follower 2. So follower 2, when filling, it will skip the broker 0, broker 3, and then from the broker 1, it will get started. So it will be get started from the broker 1. So like that, it will get filled. So here broker 0 skipped, here broker 1 skipped, and then the partitions were allocated to the brokers. Now if we can see, before broker have 6 partitions, whereas B0 broker have 4 partitions. That means we are not achieved the even distribution, but somehow we achieved the fault tolerance. Even distribution is we achieved with the parity, some disparity, but we achieved the fault tolerance. How we achieved the fault tolerance? On P0, this P0, a copy of this partition 0 is available on this B3, which is in rack 2. And a copy of this P0 is also available in the B1 of rack 1. So if rack 1 entirely goes down, still the partition 0 message is available on rack 2. Right? Similarly, any partition, if we take P8, let us take P8 is on broker 1 in rack 1. Then P8 is on broker 4 and rack 2. Again, P8 is on broker 2 and rack 1. If rack 1 gone, then still the P8 is available on broker 4 and rack 2, meaning AP South 1A gone, still the partition will be available in AP South 1B. So this is a perfect fault tolerance, right? So this is how the partition allocation will be happened. Hope it is clear for anyone. I hope it is clear for everyone, I believe. So like this. However, however, the first follower of partition 4 goes to different racks. So this is how it made. So if any of the rack is entirely down, so that means rack 1 entirely down, still we have the messages P1, P1, P2, P0, P3, P3, P4. So all the partitions are available on another rack as well, right? If one of the rack is down, rack in the sense AP South 1A region down, still the partitions are available in AP South 1B region. So this is how the partition allocation will be happens in Kafka. Is it clear or any questions, guys, here? Any questions, please ask regarding the partitions allocation. Any questions? Great. Now let us understand in these partitions, is there anyone is leader or anyone is follower? Yes, we have the leader partitions. If you can see, these are all the leader partitions, fill down leaders, and these are all the follower partitions. What is here leader partition meaning is? The leader partition meaning is, let us understand, we allocated 30 replicas among 6 brokers. Now each broker owns multiple replicas. Like B4 owns 6 replicas, 6 partitions. For example, in the above figure, the broker 4 hold 6 replicas. 2 of these replicas are the leader partitions, P3 and then P9, and the remaining 4 are the follower partitions. So the broker acts as a leader for the 2 leader partitions, and the same broker acts as a follower for the 4 remaining partitions. This is important point. Important point. The broker will be act as a leader and the broker will be act as a follower as well. Here, before the broker act as a leader for P3 and then P9, but act as a follower for P2 and then P8 partitions, which got partitioned onto this broker. Right? So now what is leader? So Kafka broker acts as a leader for all the leader partitions that are allocated to the broker. So if the broker have leader partition, for example, B5, yes, B5 have a leader. B2 have a B2 is also a leader because it have a leader partition. So like all the brokers have the leader partitions, so these all the brokers are said to be the leaders. And on the other way, these brokers are also have the non-leader partitions or follower partitions. So when the broker have the follower partition, it is said to be a follower. Simple. So the leader is responsible for all the requests from the producer and consumers. This is very, very important. So in the Kafka, the leader broker is responsible for all the requests from the producers and the consumers. And the followers do not directly interact with the producers and the consumers. Interesting topic. Please focus more because today entire theory only. Theory concept only today. And tomorrow, let us go with the producer API, practical things we will do, coding things we will do. But today, complete theoretical. Okay, so let us assume that a producer wants to.
Sir, second point, can you come again? Followers do not directly interact with producers and consumers.
Correct. So here, this is the diagram. Let me explain. So here, these 2 points we'll understand with this diagram. Okay, so that we'll get the complete picture. So let us assume that a producer wants to send some messages to Kafka topic. So here is the producer, and this producer wants to send the messages to some topic. That topic have the partitions, these many partitions we have, and 6 brokers available we have. So the producer will connect to one of the brokers in the cluster and query for the topic metadata. So producer will connect to one of the broker in the cluster and request for the metadata and queries the metadata. So all Kafka brokers can answer a metadata request. So this broker, all brokers can answer a metadata request. And hence, the producer can connect to any one of the broker because all these brokers have the metadata request. Why? Why? Because a copy of the partition is available, right? For example, P2 is here. P2 is here also. P3 is here. P3 might be here also. So a copy of the partition is available. So definitely metadata will be available on all the brokers. Hence, producer can connect to any of the broker and query for the metadata. This is clear. The metadata contains the list of the leader partitions and their respective host and then port information. Assume. Now the producer has a list of all the leaders when he got the metadata, right? It is the producer that decides on which partition does it want to send the data because it know now all the leader partitions. So on which leader it should have to go and then connect. It depends on the producer. And accordingly, the producer send the message to the respective broker. Let's say here, I have all the leaders partitions list. So all this B0, B3, B1, B4, all these are leader partitions list I have. So leader brokers list I have. Let me choose to send a message to this broker 0. Right? Now, that means the producer directly transmits the messages to the leader. On the receiving the message, the leader broker persists the message in the leader partition. Because if you can see, this is the leader broker assume. Leader broker may have the leader partition here. One partition may be the leader partition here. So it will persist that message in this leader partition and send back the acknowledgement to the producer. So similarly, when a consumer wants to read message, it always reads from the leader partition. So in the just below figure, whenever a producer wants to send a message to a partition 3, so when a producer wants to send a message to the partition 3 or the partition 9, maybe partition 3 or maybe partition 9, 2 partitions are there on the broker before. 2 leaders are there. 2 leader partitions are there. So the producer wants to send either to the P3 or to the P9, right? Then it will reach out to the, in order to send the data, it will reach out to the broker, which is having those leader partitions. Similarly, consumer will also go to that broker and then takes the messages from the leader brokers. Now here we said one point. The followers do not directly interact with the producers and consumers. That means here P2, P3 are the leader partitions, whereas P2 is the follower partition. So in this communication, if you can see, producer will talk to the leader partition. Similarly, consumer can also talk to the leader partition, but not the follower partition. follower partition. That is the meaning of point 2. Got it right, Parshram? Is it clear now?
Yes, sir.
Perfect. Perfect.
Sir, I have one question, sir.
Yeah,
So that means the producer and consumer can take a call to on which broker they want to send, depends on the
exactly.
leader partition, right? But
Exactly. Exactly.
but like once we check the controller, like there was
Hmm.
one out of like uh, from my point of view, like all the leader partitions, we should have a common leader. Like
That is
we,
controller. That is controller. Controller
but
word is different. Leader word
but
is different. Follower
yeah,
word is different.
but
Hmm.
here the producer is directly interacting with the leader, but ideally it should interact with the controller, and controller should decide which uh, leader broker it need to serve with.
Exactly. That will be happening. Usually Kafka producer
Mm-hmm.
will talk to the controller by giving the leader partition information to the leader partition information and then broker information to the controller. Then
Okay, because
controller will route it to the leader partition or the broker.
yeah,
That
yeah,
will happen.
because
So,
because that image is not shown here. It's directly interacting, like producer
correct, correct.
directly
Why?
interacting with
Because
the leader.
why? Because if we add them, we confuse between those two words,
Mm-hmm.
controller and then the leader. Will
Mm-hmm.
confuse. That's the reason.
Mm-hmm. Okay, that means
Okay.
it's a
So,
straightforward. Producer and consumer will always interact with the controller only. That controller will take a call depend upon the producer and consumer request. Okay, from which leader broker it need to serve with, and then accordingly.
exactly.
Okay, got
Exactly.
it, sir.
So
Many
the,
thanks.
the point here is the
Mhm.
consumer and then the producer should not speak to partitions, follower partitions. That is the point.
Okay,
Great.
sir. Thanks.
Yeah.
Sir, I
Sir,
have a follow-up question.
Ah.
one. Yeah, man, go ahead.
So,
Go ahead, go
so
ahead.
we said that. Thank you. So we said that the partition, the leader partition, for example, right? So your producer got the information of what is the leader. Okay, who is the leader, right? But
Correct.
before sending the message, actually that broker went down, which was having only leadership of that single partition. Okay.
Hmm.
So in that case, how the failure is handled, because
Okay.
we want to
Okay.
send the message, but it's down. Yeah.
Wait for some time because Parsuram also asked the same question. There is a concept of in-sync replicas. So there, just wait for some time. Your
Sure.
questions will get resolved.
Sure.
Yeah. So, okay, what is follower now? We understood what is leader.
Sir, one question here regarding the controller.
Hmm.
So controller is a broker itself, right?
Controller is a broker itself. Yes.
Okay,
Yes,
so
obviously.
yeah.
Hmm.
So whenever the broker is a leader, right? So it will be decided it is a leader to some of the partitions, right? Not maybe the complete partitions, right?
Exactly.
The leader is decided based on the partitions, which partition it is going to lead, right?
Exactly. So that is
So
what a leader is said to be. A broker is said to be a leader if it have the leader partitions. Got it? No?
correct.
I repeat.
Yes.
Exactly. Yeah. Go ahead now.
Now, so suppose I am little bit misunderstanding regarding the controller concept, right? Whenever the controller will be there, right? So it may be a leader, right? Because it may have some leading,
Exactly.
may be leading some partitions, right?
Correct.
Then how it will be decided, right? For other brokers, right? Which should be routed from the producer.
So it depends on what exactly the same answer, leader partitions. So let us go a little top here and then understand that. See this diagram. Assume B0 is the controller, B0 is the leader for P0 and then P6. Okay. And B3 is the leader for P1 and then P7. Assume now the producer wants to produce the messages to the P2. So the first producer will talk to the controller, query the controller. Controller will route that producer called to the appropriate, meaning wherever this P2 partition as a leader, that broker it will go and then call it. If producer wants to send the messages to P0, which is a controller, which is a leader. Now, if we can observe carefully, leader partitions are not duplicated on the brokers. This is the first point. Leader partitions are not duplicated on the brokers. So obviously, if the controller itself is a leader, it will have the information of the partitions that the producer wants to send the message. So obviously, it will serve those messages by allowing the producer to connect to those partitions. Meaning, am I answered? Parshram, am I answered?
Yes. So it will contain, means it will plays a dual roles, right? As a leader, as a controller, and it have information about its partition and also information about which broker should be routed based on the producer's request, right?
Exactly correct.
Okay. That means the designer is so intelligent.
That's true.
Even sir, we can figure out one more point, like if any of the broker which has the leader partition goes down, so that information will always there with the controller, right? And even he will be the person who will distribute the load, like the leader partition to the available broker now, right?
Correct.
So once the producer wants to produce on that broker which recently got down, so controller will have the new broker information with it. Okay, this is the new broker for this particular leader partition.
Correct.
Right, where I want to reroute the request.
Reroute it. Yes, that's true.
Okay, got it, sir.
So that's where the
and zookeeper will decide, right? Suppose controller fails, right? R1 B0 fails, right? Somehow it got some issue. Now zookeeper will came into role, right?
Exactly. Zookeeper came into the role to elect
controller.
Exactly. Correct. Okay. That is what happening. Zookeeper will takes care of the broker's management. Where controller takes care of broker's task management.
Oh, that's the true line actually.
Correct. Yes. Okay, so let's go to the followers now.
Sir, one more question.
Okay.
So it's a little bit technical because some people don't know. So whenever you are in the producer, right? In the we are using @Kafka producer, right? So that case we are mentioning bootstrap servers, right? Bootstrap servers basically these brokers, right? How many brokers you have, correct?
Correct.
And this case we don't know from these bootstrap servers who is the controller, who is the leader.
We don't know, obviously.
Right. But then how and who decides? Again, zookeeper will plays the role from which.
Correct, because the broker's information will be available at the zookeeper only.
Acha. Then why are we directly communicating to zookeeper rather than we're communicating to bootstrap servers?
So actually zookeeper is to manage the brokers, but zookeeper doesn't have this routing, or zookeeper doesn't have these partitions, or zookeeper doesn't have these followers. Right? Okay. It is just to manage the brokers. That's it. Whereas we are sending here Kafka producer. Producer will always send the messages to the leader partitions. Leader partitions are available on the brokers. That's how we will mention the brokers in the bootstrap list.
Okay, so bootstrap servers also have information about its zookeeper, right? Who is controller?
Exactly, correct.
Okay, so there will be a backtrack. When the application label, the Kafka producer, we are mentioning bootstrap servers. We are connecting to bootstrap servers. Inbuilt bootstrap server, it's information about zookeeper, right? In the server.properties file, right?
Correct.
Okay.
Correct. I think once we start Spring Boot application, tomorrow we'll discuss this producer API. There is a nice architecture, internal architecture of the
Okay,
producer.
got it.
So we'll get a lot more things there.
The means actually controller is the main thing for routing and all the things will be happening, right?
Correct. Task management and all, routing, task management, everything. That's the reason if we can see our this query, so we can query even like this /get controller /get controller / we can say, let me not IDs because IDs not existed. Broker ID.
I think broker/ID, sir. One of the slide I saw.
Controller, yeah. Controller /brokers/IDs. Yeah. Something now we got. No. So there is an API
Brokers.
actually. This brokers, na?
Can you try brokers, sir?
Yeah. 1 minute. Sorry, I just 1 minute. Yes. Now ls space / we have the controller epoch and the latest producer ID black and all. So let's get /controller, or let's see this one, ls /controller. This won't gives us anything, and let us get /controller. It is giving us the controller, and here inside the controller, if we want to find the broker ID, let's say 1. No, it's not taking. What you're saying? Brokers /IDs, right?
Broker/ID, sir.
Brokers /IDs. No, it is not
Broker ID.
Not broker. Usually it will be brokers. Yeah, even this is also not existed. I'll come back. So this is kind of an API. So which will give us all the information. I'll come back actually. I mean, how to play with this API going forward, we'll see. I'll also just come back how we can get the other information. What is this controller contains, and then how it is routing and all. Let us going forward try to understand. I'll also come back with this one. Fine. So mostly all our questions got resolved, I believe.
Sir, I have a question here.
Yes.
Yep. See, when the controller goes down, suppose broker 0 is getting down.
Correct.
When the broker 1 is getting updated, the new controller again. So broker 0 has the status of all the leaders and the followers and everything. So how this information is getting updated to broker 1, the new
zookeeper.
Oh,
Zookeeper have.
Okay.
Zookeeper is the controller, not controller. Zookeeper is the administrator, basically, for all these things.
Okay.
Yeah. Okay.
What happens if zookeeper goes down?
That is, we have to maintain the zookeeper in high available. That is good question. Obviously, single node clusters, that is also possible. But if the zookeeper will goes down, then these brokers will becomes the orphans. They don't know what to do. They are tries to keep on connect with the zookeeper. They fail to do, and hence they don't take any data from the producers. Got it? Because broker's first initial point in touch is with the zookeeper. The zookeeper is down, then they are trying to keep on connecting with the zookeeper. Ideally, we have to maintain the replica of the zookeepers. So in real time, we will do that actually. Makes sense, huh? Got it, right?
Yes, got it.
Sir,
yeah.
One more question, sir. Sir, at producer site, whatever connection URL we generally mention, it is basically the zookeeper connection URL or broker connection URL.
See this one, our producer, producer.bat. In the brokers list, we have given the one broker, broker 0 list, controller broker list we have given, right? Similarly, we may give more brokers as well. But usually, while producing, we will give the brokers list, not zookeeper.
Sorry, this one 9092. This port for zookeeper.
Not zookeeper. Zookeeper port is 2181. 9092 is our broker 0. We can see here as well.
Okay, so suppose
Got it?
suppose this broker 0 got down. Okay, so then how then it will be able to connect to broker 1? Because
That's what here. I got your question. That's what here we will maintain all the brokers list we will maintain here. Okay. Let's say we have 3 brokers. We'll maintain all 3 brokers list here as part of the producer. So if this down, zookeeper immediately will elect one of these 2 as a controller. So then obviously producer will talk to the controller, then the controller will route it to the leader partitions, meaning leader brokers. That's the same flow. Got my point?
But sir, here, yes, but sir, here you have mentioned only broker 04, but it means we have to mention all the broker port over here, right, sir?
Correct. We have to mention broker list actually. So I just have taken only one broker because this is to demonstrate from the command line, but in real time, we will take more than one broker.
So with the Spring Boot application, tomorrow we will give the broker list here.
Correct.
Okay. And one more thing, sir, like the diagram which we are showing, like it's in one region with 2 availability zone. What the zookeeper was running, right?
Correct.
So if we want to highly available, so we will take another region to a different physical location with some availability zone in it, and to make the zookeeper up and running. So,
correct.
Right? Okay, sir.
Correct.
Sir, I have a follow-up question on this zookeeper going down. So we know that everything inside this like cluster broker, everything is handled by the architecture, and in case of failure, right? But it may happen that in production, right, you have with problem with this zookeeper. So are there any ways to recover, because all the messages produced by producer is with the brokers, right? So in production, really we do have any steps to recover, or are we going to cover that as well? How to recover from that situation?
So basically, let's say here we have one zookeeper and here we have another zookeeper. So these zookeepers will set up in sync. So like this.
Okay, we have backup. Okay.
So now let us assume the requests are handling. You got right? Yeah. So requests are handling by this one. This downs, then this request will be taken by this one. Then it will go and then serve. Mean the time it will be come back. Right.
So it's not the single point of failure, but we have a backup zookeeper as well, which will take care of this case.
Correct. Replication.
Yeah.
Yes.
Yeah. Okay.
There will be LB on top of these 2. So here LB comes here on top of these 2, where LB will group these 2 zookeepers together. So LB will come here. So this is the LB. So producer will not producer usually, but the brokers will use the LB. Maybe they will connect to either of the zookeeper. Okay.
Yeah, got it.
Yeah.
Sir, just one query, sir. So, any like message we can get, like if any of these is down, like zookeeper or whatever, maybe broker is down, like.
Okay, you mean to say how the message, where the message will be stored and how it will be?
No, sir. I mean, if suppose broker 1 is down like that, like any application will be there, like we will get the email or some message like that.
No. Alerting system, something.
Alerting system.
Alert, yeah.
No, actually here we are in distributed management system. What we need to do, we definitely should have a self-healing mechanism. Meaning
eye contact we should have on all the things.
Correct. So for example, B0 down. So B0 down, then B0 should have the self-healing mechanism. It should have to reconnect back by means of somehow, maybe, self-healing, or maybe in place of it, we should have to come with the another B0 or something like that. So that is the reason we'll go for what? Kubernetes setup. So this itself, Apache Kafka itself is a masterless cluster, right? So to have the Apache Kafka setup, multiple setups, we'll go for the Kubernetes replications. So one setup have some issue, immediately other setup will come. In the one setup, if the broker have the issue, then other brokers will automatically get elected as a masters. So here, within the one setup, within these brokers, there is no problem for us. But the problem is what? We don't know how much time this B0 will take to come back. Maybe it will come back, maybe it don't come back, right? So we need to write kind of a watcher where the replicas of the brokers always file. So that is what we'll discuss, the concept of ISR, in-sync replicas.
Okay.
So here we can see the concept, in-sync replicas. Follower lag 10 seconds. So we'll discuss about this tomorrow, guys.
And
In-sync.
one more question, sir. And does we have any like page to monitor like how many are running, or when it is down, like monitor?
Correct. So Apache Kafka we don't have. We have the open source tools only. But for the Confluent, we have the nice GUI. So Confluent, I'll try to set up. Maybe in the next weekend, we'll work on the Confluent. So I can showcase the dashboard and all. 14 days trial or something they given. Yeah.
Yes, sir. I checked that.
Okay,
so,
folks.
So can you explain the Kafka Connect like any day?
So Kafka Connect is out of syllabus, right? I told at the beginning of the course. Streaming and KSQL and this one. What is this? Cluster architecture, storage architecture, and producer API, consumer API with 2 projects. This is what our syllabus.
Okay. So
Kafka Connect, I'll guide you. If you want to go through the Kafka Connect, I'll give you the documents probably. Not right now immediately, but I'll give you the documents if required. Just go through them.
So can you please explain the binder concept in the Kafka?
The Spring Clouds, basically, when we go with this Spring Cloud stream, there the binders concept will, source sync binder concept will come. Yes. So we have a topic called streaming, right? Streaming.
Yes.
In that streaming, I'll take the Spring Cloud stream only. I told video streaming, end-to-end video streaming, right? So using Spring Cloud stream, let us do that. I'll explain. Source sync binders, I'll explain.
Okay.
Yeah.
Thanks a lot. Sir.
Okay, folks. I don't have the power right now. Shall we wind up now and then let's connect tomorrow at I think 7 a.m. or 8 a.m. 8 a.m. right? Yeah, 8 a.m.
8 a.m.
8 a.m. Yeah. So let us connect 8 a.m. guys. 8 a.m. Let us connect. Thanks a lot, folks. See you tomorrow. And
thanks a lot, sir.
1 second, sir. Followers. I mean, if we finish that, will be.
I'll explain followers tomorrow.
Actually, we need to continue, I think, from followers.
Correct. From the followers, I'll continue. Yes. Leader, we understood very well. Similarly, let us continue from the follower.
Because
so follower.
We would like to know, like, what is the role of follower if leader is like.
We will discuss them tomorrow. This follower, all followers are trying to act as a leaders. So in order to do that, what these guys, these are cunning guys. These guys are always tries to monitor these leader partitions, and always they will, sync with these leader partitions to make themselves as a leader if any of the leader partition will goes down. So we'll discuss them, how these will be in sync, and what is this one we'll discuss going forward. I mean, tomorrow we'll discuss.
Sir, you have some demo session tomorrow at 10 a.m.
10 a.m. Key clock. Yes.
Right?
Yes.
So if required, we can connect at 7 a.m. also if all agrees. If we want to cover some more topics tomorrow, like depends on all persons' availability.
Send
And
one
if
poll
required.
message in the hour. Yeah.
No, 7
I'll send
is
one
not,
poll message.
7 a.m. is not possible, sir. I don't think. For me.
Yeah, that's okay. That's okay. Otherwise, that's okay. We have the time, right? That's okay. Don't worry, guys. I already have completed this 3 batches, so I'll get a lot of time in from the next weekend onwards.
So that's what I mean. Microservices is not yet started, sir, in the batch. So is it recommended to click or attend the session? Key clock.
Which one? Which one? Key clock.
Microservices key clock.
Just attend.
Okay.
Sir, the microservices batch will be started from 15th May, right, sir?
Spring Boot microservices, correct. From 15th onwards, it's 7 a.m. IST.
So